All right, test, test. Can hear me? Hopefully, maybe, hopefully this is my mic is being recorded. But essentially, we're going to see what the difference is between constructive and destructive interference. First and foremost, what is interference? Interference is just when two waves they sort of meet up, they can either have destructive or constructive relationship. And the difference between the two is very simple. So constructive is, say for example, you can already see it from this, when the path lengths are equal, the waves are in phase and undergo constructive interference. So what this means is, uh, when two waves, say for example, this is just uh, wave 1, and this is wave 2. They have the sort of same wavelength. So when they interfere or when they meet, okay, maybe I think it's supposed to be the same now. It's supposed to be the same. I can't really get it to be the same. But essentially, what's supposed to be is like they're supposed to essentially become one wave. So this one wave, when you add them up, because it's a sine wave, right, you either have 0 or -1. I mean, sorry, +1 or -1, right? So when they add up, right, you essentially, oh, at this point, it's because it's two waves, it becomes 1 plus 1, so then it becomes 2. And so then it constructs essentially a different wave. So over here at this point, it becomes -1 plus -1. Then it becomes -2. So then there's a different point here. And then it's the same over here, and then it's the same over here, and then it's the same over here, and then it's the same over here. So then essentially you get a different wave. A different wave is constructed. So then it's essentially amplified. So this is what a constructive interference is. It's essentially when these two wavelengths, when they when they meet up or when they interfere with each other, they have these same sort of wavelengths, so then they amplify each other. They add up and then they essentially create a different wave that is amplified. And now a destructive interference is, say for example, you have two waves. You have two waves here. Wait. You have two waves, and now this is wave 1. This is wave 2. My gosh, my drawing is so bad. So now, when these two waves they sort of interfere with each other when they meet up, you sort of get something like let me just try to it's supposed to be like this, but it's kind of bad, so I'll just draw it again. But essentially, you get something like this. So here now, you can do -1, 0, sorry, 1, 0, -1. So here, this one is 1, this one is -1. This one is 1, this one is -1. This one is 1, this one is -1. This one is 1, -1, 1, -1, 1, -1, 1, -1. So when you add these two, 1 plus -1, then it becomes 0. So then these waves, essentially they cancel each other out. So then the resultant wave is 0. There's no wave. So that is a destructive interference. And how does this relate to the OPD, the optical path difference, right? So essentially what the optical path difference is, when you have two waves, essentially, and they meet up at a point, they travel different at different, they travel at different wavelengths, okay? And so when the wavelength is like here you can see when the wavelength is one whole wavelength. This is, you see over here, this is essentially another wavelength. But essentially, when these two waves, say for example, they meet up at this point, and then the source is from here and from here, and then they meet up over here. They meet up over here. This is a bit bad though, but when the difference between like this wavelength and this wavelength is going to be different. And when the difference between the two wavelengths is one whole wavelength, essentially like one wavelength of this, then it's a uh, it's a constructive interference. Why? Because the reason why is because when they meet up at this point, right, they're going to be in phase. Essentially meaning when they meet up at this point, the two waves are going to be the same. So then when they're the same, right, the same concept as this one, they add up to amplify. So 1 plus 1, they add up and to equals to 2. So then it becomes it sort of amplifies it at this point. And over here, when the path difference or when they are the same, it's the same as this one. At this point, the waves are going to be in phase, meaning they're going to be the same, meaning the 2 points are going to be at like 1, 1. So then they add up to become 2. So then at this point over here, it's going to be, it's going to create a different wave over here. That's why it's constructive. But over here, now, when the difference between these two waves are a half, right? When they're at a half, when they meet up at this point, because it's only a half, at this point, these two waves, this is the source of wave 1 and this is the source of wave 2. These two waves, when they meet up at this point, the waves are going to be sort of like this. So one is going to be at 1 and the other one is going to be at -1. So at this point, it's going to be a destructive interference. So essentially, it's going to, uh, it's yeah, it's going, it just cancels it out lah. So yeah, that's just what it is. That's the difference between constructive and destructive interference. Hopefully, it makes sense to you. It makes sense to me. But honestly, for the quiz tomorrow, I don't think this is going to matter much because I was doing the tutorial. I was doing the tutorial here, and it didn't come up as much. But I guess this is more like theory lah. Because it is something that you have to know to understand like the double slit and the single slit and whatnot lah. Honestly, the most important I think is probably the uh, diffraction grading one. It's all the way at the bottom, the diffraction grading one. Because this is what our full lab report was on, right? So I'm like 100% sure that it's going to come up. And also, I guess like for the double slit, the teacher already said that the single slit is not going to be so important because we don't focus on that one too much, if I'm not mistaken. So if I am, then I guess you can blame me though. But honestly, what you should make sure that you know is like the difference between like the formulas between a bright fringe and a dark fringe. Essentially, dark fringe is here, where can I find it? This is a dark fringe and this is a bright fringe. They have two different formulas. So you have to make sure that you read the questions carefully because in the tutorial they came out once or twice, I forgot. But if it says bright fringe, then you use this formula over here. It says dark fringe, then you use this formula. All right, that's it. Bye. Good luck. And all the best.